Quadrilaterals. This unit's all about quadrilaterals. We're going to start by naming a few quadrilaterals, hopefully with a bit more of a mathematical frame of mind than Hope did here with Bob, Sam, Kate, Harry, Edison. That's not what we mean when we say name a quadrilateral. Different quadrilaterals, four-sided shapes, have different names based on their sides, angles, and properties. First one we're going to talk about is what's called a trapezoid. You can identify a trapezoid because it's got at least one pair of opposite parallel sides. So the third and fourth side could do whatever they want, but you'll notice that we've got parallel sides always happening on a trapezoid. So two parallel sides, and then the third and fourth side, they can go whatever direction they want. That's a trapezoid. Kites. Kites have two pairs of consecutive congruent angles. The traditional shape of a kite looks like the kite you might fly in the sky, but it doesn't have to necessarily be that shape. You notice this one, the second one here, dips in. As long as the two sides next to each other are congruent and the two sides next to each other are congruent, that makes it a kite. The third type we're going to talk about, and we're going to spend a little more time with these, are called parallelograms. Parallelograms, similar to a trapezoid, have opposite sides parallel, but with a parallelogram, both opposite pairs are parallel. So what we end up with are these various types of parallelograms where sides 1 and 3 are parallel and sides 2 and 4 are parallel. And they can be all shapes and sizes, but the important thing is all the sides are parallel to their opposite side. So digging into parallelograms a little bit more, we have what are called rectangles, and these you're probably very familiar with. Rectangles come with four pairs of right angles. As long as there's four right angles in the parallelogram, we will say it is a rectangle. This is contrasted with the rhombus, or rhombi for plural. Rhombuses have all four sides congruent. All four sides are exactly the same on every rhombus. It's a special type of kite because remember, a kite had the two pairs of congruent sides. Now when all four are congruent, it is a rhombus. And with parallelograms, if we combine them together with four right angles and four congruent sides, we end up with the famous square. So a square is a special type of rhombus or a special type of rectangle, but a rhombus and a rectangle is not necessarily a square. And this gets really confusing when we look at the quadrilateral family and notice that we've got quadrilaterals. We've got quadrilaterals that could be trapezoids if they've got one set of parallel sides, or they could be kite if they have consecutive sides that are congruent. Then we've got a special type of kite, which is a rhombus, which has all four sides congruent, which is a special type of parallelogram, which is a special type of trapezoid. The parallelogram has parallel sides, and the square is a rectangle. Boy, that could give a person a headache. Let's do some math with some of this vocabulary, though, instead of getting caught up on the vocabulary. Angles of quadrilaterals. Just like a triangle we knew added up to 180 degrees, a quadrilateral's angles will always add up to 360 degrees. Parallelograms also have, if it's a parallelogram specifically, that means the opposite angles must be congruent and the consecutive angles must be supplementary. This has to do with the transversal, cutting through parallel lines. So a couple quick examples here with the quadrilaterals. We've got three angles here. We're missing our fourth angle. But we know that all four angles of this quadrilateral, this four-sided shape, are going to add up to 360. So 20 plus 85 plus 40 plus the mysterious angle, which we will call x, we know that has to equal 360 degrees to be a quadrilateral. So that's 145 degrees total that we've covered, the 20, the 85, and the 40, plus x, we know that's going to equal 360 degrees. 360 minus the 145 degrees, That's going to be equal to 215 degrees. And so this is probably not to scale. This probably opens up almost like the inverted kite example with a 215 degree angle. The angles of a quadrilateral always add up to 360. But if I have a parallelogram, this is parallel because the opposite sides are parallel both direction. We know two things about it. First, we know that opposite angles will be congruent. So this x over here has to be 35 degrees because the opposite angles have to be congruent. The other thing we know is consecutive angles right next to each other are supplementary. That means they're going to add up to 180 degrees. So let's add them together. The 35 plus the 2y plus 7 have to add up to 180 degrees. They have to be supplementary angles. Well, if I combine like terms, we have 2y plus 42 equals 180. Subtract 42 from both sides, and 2y equals 138. Divide both sides by 2, and y equals 69. We could have figured out what the angle was directly equal to also by saying, hey, 35 plus what is 180, and that's 145 degrees. So we could have done it that way as well, but this problem particularly was interested in what is x and y equal to, which we have now found. So some quick properties of quadrilaterals. Opposite angles of parallelograms are congruent. Consecutive angles are supplementary. We know they add up to 180 degrees, and we also introduced a whole bunch of vocabulary for the different types of quadrilaterals. So take a look at this on your homework assignment. Let your instructor know if you have any questions.